Hello, this is the presentation video for the Mobile Manipulators course project. The group members for this project were Tyler Becker and Danielle Oliva. Going over the main components of this project, we have our overview. This project introduces a motion planner that collaboratively moves with the user. In this project, the user can control the robot through tugging or pushing on the robot end effector and effectively using the end effector as a joystick for the mobile base movement. The mobile base plans for a trajectory implemented with a potential fields planner, which will be later explained in this presentation. For the use case of the manipulator arm, tugging is simulated using a slider GUI that allows the user to apply forces in the XY direction, positive or negative, depending on where the slider position is. And when the slider GUI receives a X and Y vector, the sum of these forces are then translated to a trajectory-based movement for the mobile base. As for the mobile base, a potential fields planner was used for online navigation, which allowed for the robot to avoid obstacles as the potential fields planner attached repulsive forces to obstacles in the space, and as the robot navigates the space, it was effectively able to navigate between them or away from them. And as the robot is being moved in the space, it is following the direction of direct input from the end effector at any given point. So now let's go ahead and take a look at how this works and what it looks like as a demo. Here we have the startup sequence of the program where we launch the gazebo simulation as well as our slider services and our follow program that includes the code for the potential fields planner. Here we see a force applied to it in the Y direction, and you can see the robot reacting to the force. You can also see the end effector moving based on the force, which is meant to give the user a feedback response when moving the arm. This response was implemented with a compliance controller that planned for the arm to move back to a home position at all times. So if you push the arm to a certain threshold, it will just come back to its original home starting position. Here you can see that it was given the force and it avoided the wall because it had seen that there were repulsive forces in that area through the laser scan data. And yes, that is the conclusion of the demo.